Okay, 25-minute timer, go. Take two. I'm going to try to keep this short. This is a completely optional video, but I felt that walking through the project the other day was kind of confusing. So here I'm going to, as quickly as I can, go through these 9 or so steps. And in the course of doing this, I think we will develop the ideas, and I think hopefully in a logical way, so that we can then see how they work in the file we were looking at the other day, blockchain.py, and that will set you up for the work that you were asked to do with miner.py. So without further ado, so that's 40 seconds into my spiel. Here we go. This is the tinychain file we had the other day. Pretty much unchanged, except I've added this stuff here at the top. So we made some transactions. Step one, we made a first transaction. I'm going to give some money to Steve, and then we made this little function to make proof. And all it is going to do is, we don't know, we cannot predict ahead of time what SHA-256 will give us. So we're just going to every time combine a different number, a different proof with this hash until randomly, by crazy random happenstance, we find a hash pops out that starts with a pattern that we want, and then we're done. So we made a very simple hash out of the first hash, and we passed that into the proof, into the make a proof. And then we were able to put the proof hash combo, kind of like Batman and Robin, they always work together, into the second transaction. And then we just repeated that process. We again hashed this object here. We have to turn it to a string with json.dumps. So we hashed that whole thing, and then we made a proof with that. So again, we play our guessing game. We guess and check hundreds, thousands of times until we find the magic number that happens to pop out, the pattern we're looking for. And then we put that into our third transaction. And I've added a fourth transaction here just, to make our chain a little bit longer. Okay, cool. Let's go up to our to-do list. So we made some transactions, and we found a proof for the hash of each transaction and put the hash proof combo in the next transaction. And now you might ask, why? Why have we done this? Why does this matter? So let's test. Let's test that a transaction is correct using the hash of the proof. So I'm going to, I can do it wherever, it doesn't really matter. What we're going to do, we will test that our hash of the previous transaction matches the previous hash, property. So the idea here is that we have remembered all of the transactions that we were going to look at. We remembered them all. So when you tell me, hey, the hash of the first transaction is right here, this is it, I can question, is that true? So I will go and look at that for myself. Maybe I don't necessarily trust you. So I will do like hash json.dumps the first transaction. And that had better match second transaction's proof property. Those had better match. Otherwise, there are shenanigans. So that's the first test. And second, we will test that the proof hash combo, when passed to SHA-256, does start with 000 with the pattern we're looking for. So why is this? What is this test? This test is checking that you did the work. It's easy. All I have to do is run SHA-256 once. That doesn't take me long. The hard part is you up here with make a proof, checking over and over and over again until you find one that works. That's hard. Me just checking, that's easy. This does not take long. So I'm checking that you did the work. I'm testing that you made all those guesses. That's the only way you got that proof. So if you're trying to cheat, you're going to give me some like bogus proof, that's not going to work. So I can just, I guess I could do, block hash. Well, actually, I don't have to do that. I can just go down here and grab them from second transaction. So I've already checked that. That's the correct hash. So now I can do like second transaction previous hash, because I know that that hash works. I can combine that with the proof and encode it like we did before. String with second transaction proof. Right, so those together are our combo, if you will. And I would then do combo. I'm just copying basically line 23, right? Trying to do it in a way that is like readable. SHA-256, our combo.encode. We get the hex digest out of it. And then, okay, again, I'm saying my test, those had better match, those first four had better match 0, 0, 0. That's my second test. This right here is my second test. Let me turn this into a function real quick. So I'm going to validate your block. I'm going to validate this, validate your proof, if you will. And let me see, where do I get, let's see, first transaction. I guess that's a block basically. I'll say that's the previous block. And then I need the current block. See, because I used first transaction and second transaction, but this will work with anything. This will work with anything, with any two transactions. And don't get confused that I'm calling them blocks. I'm going to go change these in a second. Okay, and this is my current block. Current block. So I'm going to call this, I'm going to name this a Boolean. So I'm going to say has matching hash. So if not has matching hash, then we'll return false. And similarly, this will be, what is this? This is checking that the hash and the proof work together. So I'm going to say, or no, has proof of work. So if not has proof of work, return false. And if we get past those two checks, then we're good. So we return true. So now we can look at any two blocks, and I can say, so let me, I'll say it again. I go down here and I say, okay, third transaction, you tell me that this is the hash for second hash. I can go check that. Let me look at second transaction. And then you tell me that you did all this work to find the proof. I can check that. I'll put them together real quick. Put together the proof and the hash, see what happens. They'd better start with the, with the pattern. That's how we can validate that this work has actually occurred. So that was number 3. Now let's turn a transaction into a block. So what I'm going to do here, I'm going to go down to the bottom. I'm going to do something very simple here. Okay. I wrote these as transactions first to give you the feeling of what we're trying to do here. But we can make this a little bit more, we can tighten this up a little bit. So the transaction for this block is, let's put all this into an object, and we'll say the sender is Layla the recipient, whatever, is Oliver, and the amount here is 15. So same deal, it's the same info, just expressed a little bit differently. I'm writing it like this well, for a couple of reasons that you'll see. For one thing, I kind of want to emphasize that it's not all about the transaction. The transaction is included here, but we're looking at more stuff than just the transaction. So when we bundle this info together, the transaction and the proof and the hash, we can call that a block. They all work together. Like that. So this would be the same deal. I would say, yeah, this block. The sender can be Joshua, the receiver can be Jonathan, the amount can be 30. So this is not all about the transaction. We started off with the transaction to show you that these are very simply objects that we are working with, and then we're hashing them the same way we've hashed other things. Not so much new here, in a way. But now I changed the blocks to emphasize that we're doing lots of other stuff here. Let me change that to a block. Let me change that to a block. This to a block. Okay, so same deal. We're evolving here. We're evolving. The first block, I guess you would also, let me see here. For this first block, we're also going to say the transaction, the sender is Tim. And we have Steve. But the first block, it doesn't have a previous hash, it doesn't have a proof. But we want all of our blocks to look the same. So we'll say the previous hash is 1, and we'll say the proof is 100. We're making those up, just so they all look the same. And if we see like the previous hash is 1, we know this is like the first block. So we turn a transaction into a block. However, we don't have to manually include this transaction this way. Let's make a transaction. Let's make a function to make a transaction. I'll call it a new transaction. And it's going to take a sender, a receiver, and an amount. And it is then very simply going to basically wrap those into an object. So instead of Tim, we have the sender. Instead of the receiver, we have the receiver. And then instead of amount, we have amount. And we could just return the transaction like that. So I could, I could make a new transaction with, Tim, Steve, sorry, Steve, I keep typing Stever, and 10. And then we can include that here with the transaction. Cool. But you know what? It would be possible for us to have several transactions here. I could put lots here. It doesn't really make a difference. Everything is still going to get hashed, and we still have to find the proof for it. If I come down here and I hash that block and then I find a proof, it still works the same way, no matter how many transactions I include. No issues. So we could consolidate this. Let's make a transactions list. So instead of returning the transactions, I just want to store this transaction into my transactions list. So when I call new transaction and I make a block, I'm going to say this is transactions. And you can just include all the transactions block. How about that? Cool, like that. And then when I'm about to go make a new block, I guess I had better, before I make my second block here, and I'm going to say this has transactions. I guess I would make a new transaction with Javier Beta 20. I guess before I do that, I would want to do, let me make sure I reset that list, right? And then I make a new transaction, and then this would just be transactions. And that way, only that new transaction is included, because I already hashed the previous transaction. I don't need that anymore. That previous transaction is included in this hash. So that previous transaction is, recorded here, memorialized in that first hash. Cool. Okay. Progress. So we turn a transaction into a block. We created a function to make a transaction. I guess I actually skipped down to 7 and I stored the transactions in a transactions list. And I showed you, we would reset the transactions list every time we want to make a new block. But again, this allows us to include many transactions in a single block, because why not? Might as well. We're already doing the work of hashing, already doing the work of finding that proof. Might as well. Now, let's do, let me think here. Let's create a function to make a block. So just like we did a new transaction, instead of manually typing out a new block, we could make a function for that. So let's call it new block. And what do we need here? Let's see, we were already keeping track of transactions, so we don't need that. Looks like we need a previous hash and we need a proof. And if we do that, then our block could be, what do we want? We would want transactions. We definitely want that. And we need transactions that are ready to go. Let's throw that in. We need the previous hash and we need the proof. Oops. Let me try that again. Previous hash. Oh, Python. Why do I have to type everything out in Python? JavaScript, I could do this with short, whatever. I will not whine. Okay, there's our block. And cool. Then we could return the block. And so now, instead of saying first block equals this, I would say first block equals new, not new transaction, but new block. New block. And as the previous hash, I would pass in 1. I could use Python's nifty little keyword arguments, proof equals 100. And that will deliver the same thing. Line 31 now looks exactly the same as these lines. Those are all the same. And so let me move this down. Next to the other blocks that we're making down here. There we go, I moved it. Yeah, there we go. Yeah, so then once again, we can, hash that and find the proof and then include it in our second block. And we would, reset our transactions. Actually, why do I have to reset the transactions? Let me go up here. I already stored the transactions there. So it's safe to overwrite that, like that. Okay, cool. So we get whatever transactions we've already made, and then we can reset that and return the block. Nifty, nifty. So I don't have to do this here. When I make a block, we're done. I can then hash it, make a proof, then we're ready to start making the second block, where I just do second block equals new block with the first, I guess, I think we're passing in hash first, right? So I do first hash, first proof, like that. There you go. And now we're, again, ready to repeat the process of hashing, finding our proof, passing it all. I guess I would need to make a transaction here with, new transaction with Joshua, Jonathan, and 30. And then we're ready to make our third block with new block and the second hash and the second proof. I can delete that. Pretty good. You can see again, we're sort of going over our cycle here, where again we're tying all of these blocks together. New transaction, Layla, Oliver, 15. But we've improved our code here by quite a bit. Now we're not having to type things out manually. New block with the third hash and the third proof. Okay, cool. Let me go back up to the top of the file, jump. So we created a function to make a block. We stored transactions in the transactions list, stored blocks in the blocks list. Aha, here's an idea. Instead of, just as we stored our transactions in the transactions list, we can make a list for blocks. But these blocks are tied together, as we see. They include the previous block's hash and proof, so they are a chain. Let's call it our chain. And yeah, I feel like I was going to do something else with that. Let me remember that real quick. Look at my notes real quick. Oh yeah, that comes in a second. That's fine. Cool. Okay. So when instead of returning the block, we can instead do chain.append the block. And that's that. So when I go back down here, I can just call new block. And then what's my first block? Oh, it's the last thing in the chain. It's the last thing in the chain. Like that. I've added it to my chain. I'm storing it in a centralized place. And that would be, the same thing here. My second block would be the last thing in the chain. Same for the third block. So all those, oops. All those change up that way. I think that's not too big a leap there. Reset our transactions, append to the chain, and now we can access the last block that we've made. Cool. Let's refactor make a proof into two functions. So that partly basically, so it looks more similar to what we have. And there's actually, a good reason for that. It kind of separates in our minds the fact that we make a proof and we're like validating a proof. So what do we have in the other? I think in blockchain.py we had a block string, we had a proof, and this is going to do basically this work here. So it's going to take a block string and a proof. I'm just going to copy it into a guess like that, right? And then we're going to hash all that up together. We do guess hash equals that. And then we do our check and we say, I don't know what you'd call it. Is valid proof maybe? Is valid proof. It's my little Boolean. So we'd return is valid proof. And by the way, if I've made a mistake anywhere typing any of these functions, it's not you, it's me. Like there's probably mistakes. Maybe small mistakes, but I'll run this file, in like a couple of minutes and make sure it all works or doesn't work. So while valid proof, we want block hash and proof. Instead of having this proof out here, let's do proof equals 0. So while is false, we'll keep iterating, and finally we return the proof. However, notice one thing here. Why should we pass in the block hash here or anything? We already have like a central place for our chain. So why don't we do, block equals chain -1? We already did the work for the other blocks, so we know we are only ever going to want the most recent one. We want the last block. And we could then turn that into a block hash, with JSON.dumps with the block. And if you remember, dictionaries and objects will return keys in different orders, and we don't want that because that will give us a different answer when we hash stuff. So we better make sort keys equal true. And we can just call hash on that. That's the simple hash. We don't really care about that. And then we're able to pass that in. I think one gotcha with this, if I remember correctly, is these functions will demand that we do make chain a global. That way they have access to it. I don't really know why they're not closing over it, but they weren't earlier for me. So just a little gotcha. I believe we have to type that there so that it's all happy. Okay. So that's how we can do make a proof. Oh yeah, this is why this is not happy here. Guess hash. There we are. That makes more sense. Probably some of you spotted me make that mistake. Yeah, that makes more sense. Get the first four of guess hash and check that it equals 000. Return if that's true or false. Cool. So we refactored make a proof into two functions. And what you want to do, to skip ahead a little bit, is your miner is gonna do this. Is gonna do both of these. Your miner is gonna be gonna get the last block, get the previous block, and it's gonna find the proof. And then it will send it to the server, blockchain.py. And blockchain.py just has to run this, essentially. It does not have to run make a proof. So you're doing all the work as a miner, and then the blockchain.py is the server. I'm at 27.5 minutes. Let me jump real quick into blockchain.py. Here's where we were before. Remember all this? So here's our chain that we made. Here's our current transactions that we made. Here's how we made our first block. Cool. Hey, here's our new block function. It just has a few extra things in our block. Whatever. We reset the current transactions. We append to our chain. Looks like we return our block. Cool. New transaction. Cool. We make a transaction. We append to current transaction. I guess we're returning the self.last block. Again, whatever. Same idea. This was a hasher. The hash function was our little helper function. I'm going to skip forward. Hey, proof of work. What we just made. Did I rename it? Let me go back real quick. I called it make a proof. We can rename this proof of work. It's the same deal. And I guess we don't really need proof equals 0 up here. There's no reason to have that there. I'm sure, again, some of y'all are probably wondering, like, why is he doing that? No reason, people, no reason. Okay, back here, it works hand in hand with valid proof. We've already seen how that works. I guess here this is bumped up to 6. Valid chain is just going to run that test that we made, where we tested it. It's going to do that for every two pairs of blocks. Every pair of blocks, as it will. So if I go back real quick, where is that? Validate proof. We validated a block. That's going to do that for all the blocks in the chain. Valid chain. Okay, skip past all that. So when we mine, we made a new transaction where we gave ourselves money. So we're going to include that. So the next person to hash a block is going to validate that. Say, yeah, you get money. We found our hash. We found our proof. We put them in a block. And we were done. So your job with Miner, as I say, is to sort of split that up so that the server here, blockchain.py, is not doing the work to find this proof. It shouldn't have to do that. Okay, I'm going to keep this short and sweet. If you have any questions, drop them in. 30 minutes. I'm a little over what I wanted to do. But I hope that helps, and I will send you this tinychain development of the ideas of blockchain.